All right, we need to break down what just happened in the AI world because it's a massive shift. You've got OpenAI, Google, and MiniMax all dropping major updates at basically the same time. And this isn't just a small tweak here or there. We're talking about a fundamental change in how software is built. So yeah, let's dive right in. Seriously, this is not just another Tuesday update. We're talking about super fast coding, crazy deep thinking, and always-on AI agents, all landing in our laps at the exact same moment. It's this convergence that's the real story here. It's a pivotal moment, and it's carving out completely new paths for AI development, and, for anyone who actually builds with this stuff. Okay, so here's how we're going to tackle this. First up, we'll look at OpenAI and their need for speed. Then we'll switch gears to Google and their focus on some serious reasoning power. After that, we'll get into MiniMax's wild economic disruption. And finally, we'll wrap it all up with our verdict on the 3 brand new lanes that just opened up in the world of AI. All right, let's kick things off with OpenAI. So their coding assistant, Codex, it's been evolving, right? And it's basically split into handling 2 very different types of jobs. You've got what you could call the long mission. That's where an agent just grinds away on a big, complex task. But then there's this other thing, what they call the tight real-time loop. And trust me, that's where things get really interesting. So what is this tight real-time loop? It's all about momentum. You know that feeling, right? When you're totally in the zone, you're writing code, you're tweaking a UI, and everything is just flowing. The last thing you want is an AI assistant that lags and breaks your concentration. You need it to keep up with you. And that specific problem, that's exactly what OpenAI is trying to solve here. And their answer to that problem is something called Codex Spark. Think of it as a smaller, nimbler version of their big GPT 5.3 Codex model. It's been specifically tuned for one thing: near instant responses. The idea is you can just toss it a function to edit, ask it to refactor something or tweak a UI element, and bam, you get a clean patch right back. The whole point is to keep you in that creative flow state without missing a beat. So how in the world are they getting this kind of speed? Well, Spark is running on some pretty wild hardware from a company called Cerebras. It's their Wafer Scale Engine 3. And if you think of standard GPUs as, the workhorse engines of AI, this is a specialized drag car. It's built for one thing and one thing only: insane straight-line acceleration. And when I say drag car, I mean this thing is an absolute monster. The chip is packed with, get this, 4 trillion transistors. And this isn't just some little side project. No. This is part of a massive multi-year deal with Cerebras that's worth over $10 billion. So this is a huge bet that the future isn't just about general-purpose AI, but about using specialized hardware to create very specific, very fast user experiences. But of course, that speed has to come from somewhere, right? There's a trade-off. If you look at the benchmarks, Spark scores a 58.4% on Terminal Bench 2.0. Now that's noticeably lower than the full-blown GPT 5.3 Codex, which hits 77.3%. But here's the thing, that gap is the entire point. OpenAI is deliberately giving up some of that raw, heavy-duty problem-solving power to get that lightning-fast responsiveness you need for quick, back-and-forth coding. Okay, now let's completely switch gears and talk about Google. They are taking a completely different approach. While OpenAI is all about chasing low latency, Google's new model, Gemini 3 DeepThink, is chasing something else entirely: specialized, super deep reasoning. It's really the other end of the spectrum. And this really gets to the heart of the contrast, doesn't it? OpenAI is optimizing for the feel of coding in real time. Google, on the other hand, is optimizing for solving these huge, gnarly challenges in science, research, and engineering. We're talking about problems where the data is messy or incomplete, the rules are fuzzy, and you don't even know what the right path forward looks like. And Google is backing this up with some absolutely bonkers benchmark scores. I mean, that high score on ARC-AGI-2, that points to a model that can actually reason and adapt, not just match patterns it's seen before. And that 3,455 ELO on Codeforces, that's basically the AI equivalent of a grandmaster-level competitive programmer. It's elite stuff. And this is where it all clicks, and you see how that reasoning power actually becomes practical. They showed this sketch to 3D printing demo that's just brilliant. The model takes a fuzzy human input like a simple napkin sketch and turns it into a concrete, physical thing you can hold. It's this perfect bridge from abstract thought to a real-world object. All right, now for our third and final player, MiniMax. And they're coming in with an angle that might just be the most disruptive of all. It's all about economics. The story of their new model, M2.5, isn't that it's the fastest or the deepest thinker. It's that it's just insanely affordable. And that affordability really forces you to ask this critical question: what if AI agents were basically free to run? Think about it. Agents only become truly useful when you can let them run constantly, letting them try things, fail, explore, and learn. MiniMax is basically betting that the single biggest thing holding back truly autonomous systems is cost. And here's their headline number. They're claiming you can run their M25 model continuously for an entire hour at 100 tokens per second for about $1. I mean, that is a price point that's tailor-made for anyone building agents. It's designed to make you stop sweating the cost of every single API call, which, as you know, can get super painful, super fast. But it's not just about the cost. They're also making a really interesting claim about how it behaves. They say M2.5 plans like an architect before it starts to code. So it'll actually break down the features and the UI design first, and then it writes the code. And if you've ever dealt with AI-generated code, you know this is a massive deal. It means better structure, way fewer rewrites, and hopefully less of that dreaded spaghetti code. And then they drop this claim, which is just the most dramatic of all. MiniMax says that M2.5 is already completing 30% of their own company's internal tasks completely autonomously, and that it generates 80% of all their newly committed code. I mean, look, if that is even remotely true, it means this model isn't just a tool or a helper. It's basically integrated into the core operating system of their entire company. So, okay, after this absolute whirlwind of releases, the dust is starting to settle. And what we're seeing are three very clear, very distinct lanes opening up in the AI landscape. Each of these companies is placing a huge bet on what they think developers and users are going to value the most. So let's just lay it all out one last time. You've got OpenAI with Spark and that crazy Cerebras hardware who are absolutely winning on low latency and that immediate, in-the-flow feel of coding. Then you have Google's DeepThink, which is winning on deep, complex reasoning for those really hard, fuzzy problems. And finally, you've got MiniMax with M2.5, trying to win the whole game on pure economics, making it so cheap to run autonomous agents that it changes everything. And really, that brings us to the final question, the one that matters for anyone actually building with this stuff. For you, in your work, what's more important? Is it that instant feedback that keeps you in a state of flow? Or is it the heavy-duty reasoning power to crack the toughest problems? Or is it the economic freedom to just let an agent run and run and run? The right answer, of course, is going to depend entirely on what you're trying to build.